Let's try a second example of pH calculation. We have a 0.28 molar lithium hydroxide solution has been prepared for a laboratory experiment. We want to calculate the H plus and the pOH value. And now we can recognize by the hydroxide ion being present that lithium hydroxide is a base. So we know that our pH is going to be greater than 7. And we know that the molarity shown here, 0.28 molar, is going to be representative of the hydroxide ion concentration, because this is a base that will produce the hydroxide ion when it dissociates into water. Okay. So it's going to be an easy calculation to get this pOH value, because we know that pOH is equal to the negative log of OH negative. Okay, similar to pH being equal to the negative log of the H plus. And together we know that pH plus pOH is equal to 14. So for our pOH we have negative log of 0.28. So we calculate it, and we get a pOH value of 0.55. Now, if we wanted to add a calculation to this example, we have pH would then be equal to 14 minus 0.55. So pH would be equal to 13.45 is what the pH would be equal to. Now, we also need to calculate out this hydrogen ion concentration. So we can work it two ways. We can take pH is equal to 13.45, which is equal to negative log of H plus. We could solve it this way. So H plus is equal to, negative log is just 10 power raised to the negative 13.45. So there on our calculators we have, if we go ahead and simplify this, we get 13.45. Okay, it looks like we get something like 3.54 times 10 to the negative 14. That's what I'm showing. Okay. Now, the other way we could do this is we could go through kW. We could do kW is equal to H plus multiplied by the hydroxide ion concentration, and we have this from the molarity 0.28, and kW is 1.0 times 10 to the negative 14, so we could divide those two and get our value. Okay, 3.5 times 10 to the negative 14 as well. Okay, and that would give us our H plus value.